Hello and welcome back to Math Class in Session. Working with rational exponents. We've learned that the word rational means fraction. So this means working with exponents that are fractions. Let's review what a radical is. A radical is one of those root signs. Kind of looks like this. And the number underneath this root sign is called a radicand. And there's another number that has probably been invisible to you up to now. It's been this thing, this number that fits right in here, and it's called the index. There's been an invisible index all along for square root of 25, and that invisible index is the number 2. So the notation means the number that when used as a factor 2 times gets us 25. And the number that when used as a factor 2 times gets us 25 is the number 5. And we've been calling it the square root of 25. But we can have other indexes. When there's a different index than 2, we have to write it. And so in this case, the third root of 8, and we call it the third root of 8. Now, this means the number that when used as a factor 3 times gets us to the number 8. And that's, of course, 2. Because 2 times 2 times 2 is 8. The fourth root of 81, we have an index 4 here, meaning the number that when used as a factor 4 times gets us to 81. And it's good to know that that's the number 3. 3 times 3 times 3 times 3 is 81. Rational exponents. A to the 1 over n is the nth root of a. We note and we remember that the denominator of the fraction is the index of the radical. A to the b over c, we've already learned that the denominator of the fraction, c in this case, is the index of the radical, and if the numerator is other than 1, like b for example, it remains an exponent on the base, a becoming the radicand. The b can be an exponent on the a, or it can be the exponent on the cth root of a, depending on how you choose to think about it. Either way, the result will be the same. i.e., a simple example, 16 to the 3/4. What this means is the fourth root of 16 to the 3. The denominator is the index, the base of the power, the base of this power is the radicand, and the numerator of the exponent remains an exponent. So it's the fourth root of 16 to the 3. And the fourth root of 16 is 2. Because 2 times 2 times 2 times 2 is 16. The number that when used as a factor 4 times to get to 16 is 2. So fourth root of 16 cubed is 2 cubed, and 2 cubed is 8. Another simple example, 27 to the exponent 4/3. I like to look at it this way. We start at the denominator of the fraction, which is the exponent. And that's going to build our expression by finding our index first. It's the third root of 27 to the 4. The third root of 27 to the 4. A little pattern that you have to learn. Now, the third root of 27 is that number that when multiplied by itself 3 times builds the number 27. And that's the number 3. We have 3 to the 4th. And 3 to the 4th is, well, 3 times 3 times 3 times 3. 81. Let's do some examples of simplifying. Here we have powers of 8 divided by 8 to the 1/2. And this is all predicated on the fact that there's nothing but multiplication in both numerator and denominator, and the bases are all the same. In this case, 8. So we can just add the exponents in the numerator and subtract the exponent in the denominator. And now it's adding and subtracting fractions. Common denominator leaves us 8 to the 4/6, and 4/6 reduces to 2/3, and now we have our expression 8 to the 2/3. And we can start at the denominator of the fraction and go in a little circle. Third root of 8 squared, like this. Third root of 8 squared. Starting at the denominator in the fraction, using it as our index, the base of the power becomes the radicand of the radical, so it's third root of 8 and squared. And third root of 8 is 2. 2 squared. And 2 squared is 4, of course. I've brought forward our law for rational exponents. And let's look at something. We just did this, the third root of 8 to the 2, and we did it like this, the third root of 8 squared. We could, if we chose, square the 8 first and get 64, and then take third root 64. The number that when multiplied by itself 3 times gets us 64 is 4. The purpose of this example is to illustrate that we can do this little exercise differently. In this case, we took the third root of 8 squared, and we squared 8 first to get 64 and took the third root of that. We could take the third root of 8 before we square it, like this, and the third root of 8 is 2, and then square that. Comparing these two methods, we see that we can square the 8 first, or we could take the third root of 8 first and arrive at the same result in both cases. It will often be convenient to take the third root first because it keeps the numbers lower. Some examples using exponents. Consider a over b to the minus 1. Negative exponent means 1 over the base. So it means this, literally. And this is now 1 divided by a over b, and we know that that means invert and multiply. Invert the divisor and multiply. So we have b over a times 1. 2 over 5 to the negative 2. Well, the negative sign in exponent means that it will be invert the base, because the negative sign inverted a over b, made it b over a, so the negative sign on 2/5 will invert the 2/5 and make it 5 over 2, but still squared. And now we'll have to square the top and square the bottom. Simplifying, just recalling and exercising, 3 to the minus 2. This is 1 over 3 to the 2, because that's what a negative sign means when it's in an exponent. And this is 1 over 9. 16 to the 3/4, we encounter this and we know what to do. It's the 4th root of 16 cubed. I did it this way because I don't want to cube 16. It takes me into very large numbers. I'd rather 4th root 16 first and then cube that. 4th root of 16 is 2, because 2 to the 4th is 16, and 2 cubed is 8. Doing another example here, 125 to a negative fraction. This means 1 over 125 to that same positive fraction. And we've learned that this means third root 125 squared, kind of like this. I definitely don't want to square 125, so we'll cube root it first and then square that. Cube root 125 is 5, and then that's easy to square. A fraction to a negative 2, this is just review. We recall that the negative sign in the exponent means invert the base. So 2/3 becomes 3/2, and the negative sign has now disappeared. And then we square the top and square the bottom. We have a fraction to a fraction. We recall that we don't really need to write this index. If we didn't write an index 2, it would still be the same expression, square root 16/9, because the understood index is 2 if it's not written. But I thought I'd write it in this instance. And now to take the square root of a fraction, we take the square root of both numerator and denominator. We have a fraction to a negative fraction. Well, we do it step by step. The negative sign inverts the base. That's what negative signs do when they are in exponents. We note that the result is still positive. It's just inverted. And the negative sign is gone. And now in both cases, we'll take third root and then square, both the top and the bottom. So we could do this almost mentally. Third root of 27 is 3, and then square that and get 9. So we know the numerator of our answer is going to be 9. And looking at the base, third root of 64 is 4, and 4 squared is 16. So the result here will be 9 over 16, but we can take some steps. Third root of the whole thing. Now third root of that fraction is third root of 27, which is 3, and the third root of 64, which is 4, and it's all to be squared, and square the top and square the bottom. There's our 9 over 16, as predicted. Another example, provided that the only operation in those brackets is multiplication, and it is, then this discussion holds true. The 3/4 is applied to every exponent of every factor. The 16 has an exponent, it's an invisible 1. So it'll be 16 times 1 times 3, it'll be 16 to the exponent 1 times 3/4, it'll be x to the exponent 4 times 3/4, which is 3, and y to the exponent 12 times 3/4, which is 9. And all we need to do to simplify this is take 4 through to 16 to the exponent 3. Starting here and building this expression using the denominator as the index, using the base as the radicand, and using the numerator as the exponent. 4 through to 16 is 2, and 2 cubed is 8. I've got some special notes here, which I think you need to know about. Negative 5 to the 0 is negative 1, while negative 5 to the 0 is the number 1. In the top instance, the 0 is only applied to the 5, and so we have 1 with a negative sign on it. In the next instance, 0 is applied to the whole expression, negative 5, and so it becomes 1. Another example, negative 3 squared means square the whole expression, and a negative times a negative is this positive. As opposed to negative 3 squared, which means square the 3, get 9, and then put a negative sign on it. The notation has meaning. Negative 1 to a large or small even number. Well, the negative 1 factors, because this means negative 1 used as a factor 112 times, those 112 negative 1 factors cancel in pairs, and they all cancel away. So it's the same as multiplying by 1. As opposed to the situation when the exponent is an odd number, the negative signs still cancel in pairs, but there's 1 left over. So negative 1 to an odd exponent is negative 1. Let's do questions backwards. Square root 5, write it using exponents. Well, we know the denominator of a fraction here must be 2, and since fractions make root signs like this must make fractional exponents or rational exponents. with a denominator of 2 and a numerator of the 1 that's on that 5. Here's another expression, and our goal is to write it using exponents. The denominator will be 3, and the numerator will be 2. So it will be 7 to the 2/3. And I've included this because let's do an example that has a decimal for an exponent. 0.4. Well, we know that's 4/10. And we know that 4/10 reduces to 2/5. And now if we could only go the 5th root of 32 to the 2, we'd be done. So it's the 5th root of 32 squared. Now I don't want to square 32, so we'll take the 5th root first. It's 2 squared, because 2 to the 5th is 32. And 2 squared, of course, is 4. And so we can evaluate expressions that have decimal exponents by turning them into fractions. Yet again, we have an expression and we want to simplify it. So since fractions make root signs, these root signs that we see, they make fractions. The fraction here is the denominator 2, so it will be x to the 3/2, and this will be x to the 2/3. Kind of like this. The denominator here will be the index. So this index 3 becomes this denominator 3. And now when we multiply powers of the same base, we keep the base. And we add the exponents. With a common denominator of 6, adding the exponents gives us 13/6.